SWR meters make you stupid. That was the title of an article written by Eric Nichols, KL7AJ. And he's right. A large number of ham radio operators have what I call SWR derangement syndrome. They're obsessed with SWR when, in the HF bands, SWR is usually of no real concern. In that respect, we are no different than CB radio operators who we don't expect to have any technical knowledge. The article argues that hams often misunderstand and misuse SWR meters, leading to myths and confusion about transmission lines and antennas. Nichols, he traces the history of antennas and transmission lines, explaining how concepts like ladder line, the ZEP antenna, and standing waves evolved. He emphasizes these following points. Standing waves are not harmful. They are simply mathematical descriptions of interference between forward and reflected waves. The energy lies in the traveling waves, not in the standing wave itself. Standing waves don't really do anything. You just stand there. It's why they're called standing waves. Reflected power does not burn up transmitters. Instead, the transmitter output depends on the impedance it sees. Ohm's law, not SWR, determines whether power is delivered or not. So it's the impedance mismatch that can burn up the finals of your transmitter, because that creates voltage and currents that are excessive. And, the transistor is the fastest fuse on 3 legs. All right, let's continue here. A transmitter never sees SWR, only impedance. High SWR does not inherently damage equipment. Poor impedance matching does. Impedance transformation along transmission lines, quarter wave, half wave, etc., can be used deliberately for matching antennas, showing that reflections are useful tools, not enemies. Antenna tuners don't change SWR on the line, only the impedance seen by the transmitter. Reflections can even be re-reflected to boost forward power. Now, this does not mean that you get some, magic power increase. It means that full transmitter power is delivered to the antenna minus feed line losses, regardless of standing waves. The real test of an antenna system is performance, contacts made, power radiated, not obsessing over SWR readings. Now, Nichols concludes that hams should rely less on SWR meters and more on understanding impedance, power flow, and conjugate matching. Now, a conjugate match simply means an antenna tuner tunes the antenna system to resonance, allowing full power delivery to the antenna regardless of SWR. All right, now let's look at an example of why SWR in the HF bands is often of no consequence. The HF band with the most coax cable loss is 10 meters. All right, here's an online coax calculator, and we've selected LMR 400 coax cable, a good quality coax. There's 100 feet of it. We're on 10 meters, 28 megahertz. Let's give it an 8-to-1 SWR. Power in from your transceiver, 100 watts. Now, you click calculate. You have a match loss of about 1/2 of a dB. There's nothing you can do about that. That's with a perfect match. Additional loss caused by SWR is, let's say, 1.5 dB for a total loss of 2 dB. So if you got 100 watts in, you're getting about 62 watts delivered to the antenna. Now that sounds like a lot of loss, but is it really? Your total loss is 2 dB. That is 1/3 of an S unit. So if your signal drops by 2 dB all of a sudden, is the other operator going to realize that your signal dropped? No. Or what if you're on FT8 and you're getting a report of minus 10 dB, which is a kind of a normal report on FT8, and all of a sudden it becomes minus 12. Now, is that really going to make any difference? No. The additional loss caused by SWR is only 1.5 dB. That is 1/4 of an S unit. So are we beginning to see here why, even with a high SWR, 8-to-1 on 10 meters, it's really not of any consequence at all? Now, some guys are going to say, well, that's stupid. A modern transceiver cannot transmit into an 8-to-1 SWR. Well, yeah, we are assuming the use of an antenna tuner here. And am I saying your SWR in 10 meters should be 8-to-1 if using a coax feed line? No. I'd think you might use an antenna more suitable for 10 if you work that band a lot. So hopefully we see why in the HF bands a high SWR is not the signal killer that many hams believe it is. Just cut your antenna to its proper length as determined by online calculators, for example. Put it up as best you can and use an antenna tuner. It tunes your antenna system to resonance. Consider subscribing to this channel. Ring the bell for updates in 73.